Hi. In the previous two videos, we considered Samuelson's law, right, of interaction between multiplier and accelerator. Today we're going to continue with introduction to economic models that utilize second-order difference equation. Our second pick is the model that we already discussed. So basically, the Augmented Phillips Curve model, when we have the interaction between inflation and unemployment. However, of course, as we are talking about difference equations, now we are doing it in a discrete time. However, we can start with what we already know and what we were doing when we were discussing differential equations. Okay, so quick reminder. First, we've got expectation Augmented Phillips curve. So P denotes inflation. Alpha and beta are positive parameters. T is the productivity growth. U, of course, is unemployment. G is a parameter between 0 and 1, including 1, not including 0. Well, if it was 0, this wouldn't be expectation Augmented Phillips curve. And finally, pi denotes expected inflation. Right? So this is the relation that we've discussed in detail in a couple of videos ago. Okay, then we've got a second equation. Second equation is telling us how expectations about future inflation are formed. And we assume the change, so the derivative of expected inflation is equal to the difference between actual inflation and expected inflation times some positive parameter J. And finally, the last equation was showing us how monetary policy can influence unemployment. Here we've got a growth rate of money supply. Here we've got inflation. So over here we've got a growth rate of real money supply. And again, we've got a positive parameter K, however with minus, because of course the faster is the growth of real money supply, the lower we expect unemployment to be. Okay, and look, this model we've analyzed thoroughly, right? And we know how to solve it. We knew that it was giving us stable equilibrium, and in this stable equilibrium, we had expected inflation equal to the growth rate of money supply, unemployment equal to natural rate of unemployment, and of course, a growth rate of inflation also equal to growth rate of money supply. Look, the thing is, of course, mathematically, this equation, this system of three simultaneous equations are very, very convenient. However, it's really hard to estimate derivatives econometrically. This is why sometimes it is maybe better to use a version of this model in discrete time where actually the structural parameters of the model can be estimated at least to some extent. There is of course a problem with their identification. Okay, so moving from this set of three simultaneous differential equations, two differentials, but we can move it quite easily to the form of difference equations. All we need to do is to replace derivatives by differences. inflation in here t is equal to alpha minus capital T minus beta times unemployment in here t plus g times inflation, expected inflation in year t. Here, of course, we remember that alpha and beta are positive parameters, and of course g is somewhere between 0 and 1 close. Okay, now derivative that we see over here. We need to replace it with a difference. So we will have simply pi t plus 1 minus pi t. So this is going to be change in expected inflation, right? So this is equal to j times, and now we replace p with pt and pi with pi t. Here, of course, you remember that j is a positive coefficient. And finally, by the same token, we replace the derivative of unemployment with a difference. So we've got ut plus 1 minus ut equals to negative k m. And in here, to make calculations a little bit simpler, we put pt plus 1. It doesn't really make a difference, but it's going to be easier to calculate. And k is also a positive parameter. Okay, so look, what we've got over here is our complete model that links unemployment to inflation, expected inflation to the difference between changes in expected inflation to the difference between actual inflation and expected one, and change in unemployment relating to the real money growth. Okay, so the next thing is to, of course, solve this model. And unfortunately, I must say that in this case, setup of this is a little bit less pleasant than in case of differential equations. We will have to work a little bit harder to get one equation that we want. Of course, look, we're going to start with something simple. Let's calculate change in inflation. And we will define this change in inflation, of course, as pt plus 1 minus pt. Right? So look, we already have pt. What do we need to do to get pt plus 1? Oh, that is nothing very complicated. All we need to do is to move all the subscripts by 1 to the future. Right? So we will have that pt plus 1 is equal to alpha minus t minus beta ut plus 1 plus g pi t plus 1. Okay, knowing this, we can substitute over here, right? So we get that this is alpha minus t. Well, they will be canceling each other out, right? Because those are constants. I'm going to write it like this. Minus beta u t plus 1 plus g pi t plus 1. And then we subtract from it alpha minus t, so plus beta u t minus g pi t, right? Okay, we clearly see that those two cancel each other out, right? I'm gonna delete this because we don't need it anymore, and we will need a lot of blackboard today. And let's see what is this out of ut plus 1 and ut. So we will have ut plus 1 minus ut. Then I can do the very same thing. I can do the very same thing for pi. This time I'm just going to take g out. And now we have g pi t plus 1 minus g pi, minus pi t. And look, this is a very convenient form to us. Why? Look, here in this parenthesis, what we have is the equation number 3. So right away, I can just take and substitute this equation over here, right? So we will have that this is negative, so positive k beta m, right? Negative beta minus and minus this is plus, then we will have another minus over here, and we will have minus a k beta pt plus pt plus 1. Okay, maybe, you know what, I'm gonna keep it, for the time being, only for the time being, I'm gonna keep it in the more condensed form, not because we're not gonna open this parenthesis, however, I need to mind the space on the blackboard a little bit. So look, we will have that this is k beta times n minus pt plus 1, right? Like you see over here. Then we got plus g, and look, again, now we can substitute the second equation, right? So why not doing so? Look, j is common here, and we have pt minus pi t. And look, what we have over here actually is equation that contains an information from this entire model, right? We've used information about Phillips curve, right, first, then we've included information about the change in unemployment, and finally about the change in expected inflation. So at this very moment, what we have is all the information that is available within this model. Let me take out of this what we need, right? So what we need actually is just pt plus 1 minus pt, of course, and then the last part. So we've got here equals k beta n minus pt plus 1 plus g j pt minus I t. Right? Okay, so now that we have introduced all three equations into one, we've got all the information from the model here. However, this is still not something with which we could work. What do I mean by that? Look, here still in this equation, we've got expected inflation, and what we are going to do is we need to always have equation in just one variable alone. We're going to choose this variable to price level. With Valeria during workshops, we will practice another approach to this model, which of course needs to give us the same solutions. Okay, so how can get rid of this pi t? Well, you know, one clever way getting out of it is to calculate it out of the last equation. Because look, out of this, we can easily get that g pi t, if we move everything else to the left-hand side, is equal to p t to pt minus alpha minus t plus beta ut. Right? Okay. So this is something we could substitute over here, right? And so let's do it. So look, now we get pt plus 1 minus pt equals to k beta and minus pi t plus 1. And now, out of this, we will have a gjpt plus gjpt. And here we've got j, right, times this entire expression, right? So all we need to do just now is to substitute over here. So we will have that this j pt that was sorry, here is of course minus jpt minus plus alpha minus t j and minus j beta u t. Okay, look, right away we will be able to notice that some things here it can be easily combined, right? So I see here, for example, that I can say and combine those two expressions, right? We have common part jpt. So this is the same as g minus 1 g and that this is g minus 1 j times p times pt. Okay? So, this is the first equation we're going to be working with. But still, let's organize it. What do I mean by organizing it? Let's put all the expressions with p on the left-hand side, all the expression without, let's leave them on the right-hand side, and also let's just take unemployment on the right-hand side. Okay? So look, here we see that those two can be combined, right? If I'm going to move this to the other hand side, I'm going to have that this is 1 plus beta k times pt plus 1. Okay, and now there's going to be, now we need to combine all the, okay, let me just cut it out. So those two are already dealt with. Now we move pt's, right? So I'm going to have here minus, right? And what I'm going to have inside? 1. And if I would move this to the other hand side, it would be with minus, right? So this time, this is going to be equal to minus j g minus 1 b d. Oh, of course, plus, right? We are moving this with a minus, we take negative out, so we've got plus. Okay, so what we have left here is plus j beta u t. Okay, out of this one. And the only, so now we are done with this, All we have left is k beta m. So let's do k m and plus j alpha minus t. Okay, we are definitely getting closer, but there are still things in this equation that we don't want, and there are things that we would like to have in this equation that we don't have, right? Because look, we have in this equation only two expressions with t plus 1 plus t. So definitely we want a third one, right? Then we've got ut, we want to get rid of it. Let's do it one by one. Look, first thing I'm going to do is let me please call this equation 1. I'm going to call this equation number 1. And I'm going to make now the version of this equation that actually is just going one step forward. So look, we will now have delta. What we are trying to do here is to get like delta pt, the delta pt plus 1, right? So all we need to do, and to get it, is to move all the subscripts one step forward. So we will have 1 plus beta k pt plus 2 minus 1 plus j g minus 1 times pt plus 1 plus j beta u t plus 1 equals to beta k m plus j alpha minus t. And let me call this equation number 2. Okay. So, okay, I hope we're gonna, probably we might need this for one more minute. The model with which we are working with, so I'm not gonna erase it. However, look, what are we going to do now? We're gonna start calculating. We're gonna subtract one equation from another. So look, what we're gonna try to do is we're gonna have equation 2, and from equation 2, I'm going to subtract equation number 1. So look, I'm gonna be doing it side by side. So first thing I'm going to do is I'm going to deal with the left side, because left side is actually complicated. Right side, as you see, will turn to 0, right? So let's start with the more problematic part. Okay, so we've got that this is 1 plus beta k p t plus 2 minus 1 plus j g minus 1 pt plus 1 plus j beta ut plus 1. Okay, so this is the left hand side of the second equation, and from this I'm subtracting the right hand side, the left-hand side of equation number 1. Okay, I will need this space, unfortunately, so we need to remember the equations that constitute the model. Okay, so we've got 1 plus beta k bt plus 1 minus, so plus, right? 1 plus j g minus 1 pt minus j beta u t, and that's it. Okay, now let's do what we do always in a situation like that. Let's organize expressions with the common elements, right? So we will have, there is only one expression with p t plus 2. So this is 1 plus beta k p t plus 2. Now, we've got here 1, 2 expressions. We've got 2 expressions with pt plus 1. So why not organize them? Together as well, right? So what we need to do, over here is to add. We need to add those 2, right? So what we're gonna get now is, they both have minus in front. So now all we need to do is to start collecting expressions, okay? So we've got 1 plus j times g minus 1 plus, right, because we took minus from both, 1 plus beta k pt plus 1. Okay, finally, we've got just one expression with pt. So we've got 1 plus j times g minus 1 pt. Okay, and finally, j beta u. J beta ut. Yes, beta ut plus 1 minus ut. Okay, and I hope you're starting to see where am I going with this, right? Okay, because what can we notice over here? Look, let's do a very strange thing over here. A very strange thing over here, and I'm going to write this. I'm going to calculate, right? It's going to be jg minus g. Okay. Let's of course times 1, so it's j. And what can I do over here? Well, again, I can use our equation. For inflation and for unemployment change, which is related, which is of course here minus km plus pt. I'm sorry, minus pt plus 1. Okay. Okay, right away, let's calculate what we get out of it. So here we would have minus j k beta m. So minus beta j k m. And here, okay, and over here, we will have simply plus k beta jk beta pt plus 1. Okay, so what do we need to do next? Well, next, what we need to do is to take expression with pt and put it together with this expression. Okay? So the first part stays the same, right? We've got 1 plus beta k pt plus 2. However, now we need to add this over. We need to add this to our expression. To our expression over here. Wait, give me a second. Did I miss anything? Did I? There's 1 plus 1g. Yep, everything checks out. Okay. So, we need to now add one additional component, which is this. So we get that this is 1 plus g minus j plus 1 plus beta k plus j k beta, right? Plus j k beta pt plus 1. Okay, now let's simplify a little bit over here. Look, I hope you can see that over here we can take k beta out of the parentheses, and we'll have here 1 plus j beta give me a second. Wait. We had 1 plus beta k plus j k beta. Okay, let's use as much of these expressions as we can. So look, I'm going to take this part over here, and I'm going to simplify it. First, by taking bk out, and then by taking j out. And what will we get in this case? We will have this turns into 1 minus j times 1 plus beta k. If you don't believe me, I'm sorry, I just don't want to take more space for yet another step. Just multiply those, and you will see that you are getting exactly the same output. Okay, then we add to it 1 plus j g minus 1 pt, and the only thing left we have over here is minus j k beta. Okay, and this is enough. This is what we wanted. We already have all expressions with p on the left hand side. Okay, so now the right hand side. Look, right hand side is extremely easy, right? Because in case of right hand side, we've got exactly the same expression. So look, right hand side is equal to 0, right? bkm plus j alpha minus t minus bkm minus j alpha minus t, right? We got that this is 0. So look, of course, left hand and right hand side must be equal to each other. So we finally get that this is equal to 0. And this is the equation we can definitely start working with. However, there are some things that we would like to move around a little bit. Okay? And so, I'm gonna take everything that has P, so inflation in it, and I'm gonna leave it on the left hand side. Okay, and this, the only exogenous term, basically, so our constant is going to the right hand side. So we got that this is jk beta m. Okay, this kind of starts to look like something we are used to work with. However, there is one last thing we need to do, right? We always want to have coefficient 1 on the highest, on expression with the highest degree, right? On t plus 2. So we divide both sides by 1 plus beta k. And we get p t plus 2 minus 1 plus j g plus 1 minus j 1 plus beta k divided by 1 plus 1 plus beta k pt plus 1. Then we've got 1 plus jg minus 1 over 1 plus beta kpt equals to jk beta m over 1 plus beta k. And look, this is the equation that we can work with. This is the equation that can be estimated econometrically. However, as you see, there is a lot of parameters in the coefficients we could estimate, so there would be certain, that there would be great identification issues unless we would introduce some additional information. But I hope you can see that this is the equation we are ready to work with. This is y t plus 2 minus a1 y t plus 1 plus a2 yt equals to c. This is the equation that we know, and we know what to do with it. Okay, this is enough for the introduction to the model, and out of taking the model into the form with which we can work, right? Okay, so now that we've got this, the only thing left is to find particular solution, so our long-run equilibrium, and then find a and then discuss complementary function. So make sure that our equilibrium in this model is dynamically stable. And this is of course going to be a topic of our next video. Thank you for your attention.